Here, at the Institute of Nanoscience at Delft University of Technology, an international group of scientists is working on the quantum computer, which promises to be more powerful than any conventional computer could ever be. Made possible by a 10-year FOM grant, they are investigating the fundamental physics necessary for a quantum computer.
A quantum computer is a computer that uses the laws of quantum mechanics to perform computations. And the difference with a classical computer is that in a classical computer you have bits which can be 0 or 1. And in a quantum computer you use so-called quantum bits, which can be in a quantum superposition. So they can be 0 and 1 at the same time. The setup that you see right here is made for looking at single spins in diamond. So you see a green laser path which we use to initialize and read out the spin states. And there is some microwave components to manipulate our quantum bits. So what we've done actually in this setup is to execute a real quantum algorithm at room temperature. And this quantum algorithm is a search algorithm. It searches in an unsorted database with 4 entries. And if you're classically, you want to find an entry in an unsorted database with 4 entries, it will take you on average more than 2 times. So you can just guess, and the first time you'll probably be wrong, and the second time maybe you're right, etc., etc. But if you use a quantum search algorithm, you can do the search in one go, and you'll have the answer with 100% certainty. So that's the algorithm that we've performed here, and this is actually the first time that any quantum algorithm has been performed in a solid-state device at room temperature.
I work on carbon nanotubes. So this is a very, very tiny cylinder of carbon atoms, only 1 nanometer in diameter. And I use this to study the interaction between light and matter. And this would be useful for example, if you have a qubit in the solid state and you would like to transfer this quantum information over long distances. Then the information is better protected in the state of a photon, in the state of a particle of light.
10 years ago, or even 6, 7 years ago, companies were not interested. It was too far ahead into the future, and they didn't see any profit. You cannot make money out of it. But IBM and Microsoft have set a goal to make a quantum computer. And IBM says it can be done in 10, 15 years, which is very ambitious. But, if a big company with big money puts itself behind such a challenge, then you can make a big push. Maybe they're right, 15 years.